Swayam Prabha. Digital India. Educated India.
Welcome back, my dear students. Hope everybody is fine. This is the 31st lecture. So, each lecture, as you know, and I am repeating that, but sorry for that, is for 30 minutes. So, we will try to basically start off from where we left. So, I am Raghunandan Sengupta from the IME department, IIT Kanpur, India. So, now we will be discussing about the concept of crashing of jobs and in some way the concept of leveling of resources. So, if you remember in the last class, in general they are all standalone lectures which is happening. So, I am trying to finish off each small topics or subtopics or tertiary topics in one lecture series of 30 minutes, but this concept is intertwined with the 30th or the 29th fag end of the 29th lecture, the 30th lecture in total, and the 31st would be considering the concept of resource leveling and how resources are important in order to basically crash the jobs. So, if you remember, PERT and CPM generally consider time as important factor based on which we want to find out the critical path, what are the activities on there and what is the variances, what is the expected time and all the important things. So, further continuation of that concept we will consider how the costs are also considered. So, this slide is basically the data related to the normal time and the cost which is in the second column for jobs A till G. Then the crash time, that means if you reduce the time, so obviously there is an extra cost incurred. So, that is all this information for jobs A to G is given in column 3 and correspondingly the slopes are given. So, my apologies, in the last class there was some error in the slide. So, I will again start off from where we left. So, if you consider job A, the cost difference is 16 minus 10 which is 6 and the duration is 9 minus 6 is 3. So, if you have 6 divided by 3 it becomes 2. So, the slope which is the marginal cost increase for 1 day deduction of the time for only activity A is given by the cost of 2 rupees. 2 rupees, $2, 2 yens or 2 liras, lira is not there, like, but just I wanted to mention that. So, that is 2 units. So, correspondingly if I go to job B, it is 18 minus 9 is 9 divided by 8 minus 5 which is 3. So, 9 divided by 3 is 3 which is there, the number. So, let me highlight it. So, is the number 3 which is here, which is the slope of that activity cost versus reduction per day for activity B on a standalone basis. So, if you consider C, it is 8 minus 7 is 1 divided by 5 minus 4 is 1, 1 by 1 is 1. So, this is fine. If I go to the next one, I am going slowly, plus please bear with me. The D activity is 19 minus 9 is 10, 10 divided by 8 minus 6 is 2, it is 5. Then if I have go for the activity E, it is 15 minus 7 is 8, 8 divided by 7 minus 3 is 4, 8 by 4 is 2. For the F1, note down it is here carefully. So, you cannot reduce the number of jobs because it is due to some reason or the other. Consider this, you want to get a CNC machine and the cost for utilizing the CNC machine as being supplied by the vendor is only 5 and the person cannot try to either extend the usage or try to give you some extra benefit because his clientele are also in line apart from you. So, you who is trying to basically do this crashing of the jobs is one of the clients for the vendor. So, obviously, it means that no such request can be entertained. So, hence the cost structure is as given in the second last row, which is F1. So, there is no concept of slope here, and for the last one is 32 minus 8 divided by 5 minus 2, it is 8. So, now all these costs which I am now circling again and which I will again highlight. So, they mean that these are the linear costs. So, linear cost, even though everything is clear to the students, I am sure they are very intelligent and they have understood the concept in clearly as we explained. So, the slopes are these. So, the rate of the change is fixed. So, tan of theta is fixed. So, obviously, in case if they are not fixed, if they are non-linear, I did mention using a small diagram that how you can basically linearize them. So, the cost factor is like this. So, I use a step function such that this portion which is marked by A and B has to be replaced by a straight line. So, this straight line is basically tangent. So, this slope would basically replace that part of the curve. So, similarly, I have another tangent starting B to C, that tangent would basically replace the portion of the curve which is B and C. So, if I go to C and D, again I have to draw a tangent. So, it is not drawn very clearly and very nicely, but still I am sure people would understand that. So, if I go to C and D, the tangent at this point would be basically be the best way how you replace the curve C and D. So, all the slopes corresponding to A, B, B, C, C, D would replace the corresponding cost structure. So, activity A, consider activity A has a nonlinear cost as shown here. So, in that case for each 1 day reduction the cost would basically increase accordingly. So, it will be minimum for reduction from D to C, increase by a certain amount as it basically is crashed from C to B, again it will increase to the maximum value as it is crashed from B to A. So, the corresponding values can be found out if it is given. So, correspondingly you can have for B activity, for C activity, for D activity and all the activities which are given. Now, consider the data is given. So, data is given can be again from two viewpoints. For repetition, please bear with me. It was the critical path method concept was used. The fixed cost would be time costs, my apologies, the time would be given. If the time is given, so obviously there is no concept of variance, but consider the PERT concept is used. You have A and B corresponding to the fact this is the optimist time, pessimist time, M is the most likely time, from that you find out expected time. As you find out the expected time for each and every job, you will try to find out the variance also for each and every job. Always remembering the fact that the variances can be added for the whole critical path, because we assume the activities and jobs are independent to each other. Now, here I would like to expand this concept of independence, even though it did make sense from the calculation point of view. So, what I mean by independence is, consider you have one resource and the resource is, for this example, consider that is one very skilled laborer, a welder, or say for example, a person who does the drawing very well, or person who does the actual the concept of trying to basically utilize the engineering concept, he or she is very well. And when we are trying to basically utilize the resources of the welder for one job, we consider that the resource allocation is such that utilizing at one end the resources would not affect the resources utilization for the other end, even if there is resource constraint. That means, the independent structure should be there, which in the practical sense may not be true. Anyway, leave aside that discussion, let us come back to the problem. Based on the fact that you have the expected time, the variances, using the concept of forward pass and using the concept of backward pass. So, I write down in the second, third, fourth and fifth column the respective values of early start, then early finish, as you can see in this slide, the late start, the late finish, and corresponding to the cost structure or the one information which we had in the last slide, I wrote down the costs also. So, the costs are given in the last column. So, if we see Job A, it has got the early start of 0, job B has the early start of 0. Similarly, C, D, E, F, G have the early start as 9, 9, 8, 14, 17. Corresponding to the late start, which is basically the fourth column, if you see in this slide, for A to G are the values which is given from 0 to 17. Similarly, the early finish and the late finish for A is 9 and 9, and corresponding to G, which is the last column, if you see the values where I am pointing my finger, this is 22, which is early finish, and 22, which is the late finish. Now, based on the calculation how you do that, if you see, remember the formula for finding out the total slack, the free slack. So, we do that, and then we again draw the table, but with the necessary informations as stated. What are those? The first column is again the jobs A to G, then in the second column you have the time. Time was basically the time taken on the normal scale for each and every job, starting from A has a time of 9 till the last job activity G has a time frame of 5. The total slacks are given in the third column, the free slacks are given in the fourth column. So, as you know, the relationship between total slack and free slack is known to us, and based on also the fact that in the critical path what should be the value of the free slack, what should be the value of the total slack, we are able to find out what is the critical path. Now, if you consider the critical path, the number of days, I am not going to come to immediately to the path as such, but only concentrating on the number of days for the critical path and the number of cost which is incurred, the total concept of cost. So, if you consider the total number of days, so now first time I will basically in this whole series of lectures starting from the first to the 30th one, I generally did not go back to the last slide. So, considering they were moving in a sequence and people could understand them, I purposefully did not go back, because that would basically break the sync or the flow of the lecture. But with due permission of the students, I would like to go back to the last slide, such that it is easy for me to explain this concept of the crashing. So, if I go back to the last slide, so it gives me the early start, early finish, late start, late finish, the cost, and if I have the normal, so the time normal times are 9 plus 8 is 17, 17 plus 5 is basically the total value, which would not match with the answer, because I am going to come to that. So, what is important is 9 plus 8 plus 8 plus 5 plus 5 plus 8, 8 plus 7, 7 plus 5 plus 5. So, that is the total duration would be taken for each and every activities collectively, but that would not be the case for the critical path, which is obvious. But when we come to the total cost, remember that cost would now be not the critical path only, but the other jobs also which are there in the sequence. So, that is why I wanted to mention that. So, based on that, the total number of days is 22. So, the critical paths, if you can find out, they would be immediately very apparent from the total slack and the free slack which is there. So, if you see the total slack and free slack for A as shown in the slide, A is total slack, free slack is 0. If you see D, total slack, free slack is 0. If you see G, the total slack and free slack is 0. So, that should give you a hint the critical path what it is, and the total cost is the addition of all the cost for all the activities beside the critical path. So, now it has been replicated in the diagram format. This is the activity on node concept. So, now if you remember the activity on arc concept, so my apologies, activity on arc concept. So, the jobs which are there on the critical path considering the total slack and the free slack, they are A, D, G. So, the total time required, if you remember in the last slide, was 22. So, how do we get 22? 9 plus 8 is 17, 17 plus 5 is 22. But if I want to find out the total cost would be for activity A, activity C, activity B, activity D, activity E, activity G, activity F, all combined together. That was the total cost which was coming. Now, let us crash the jobs. So, crash the jobs in such a way that we will try to see that how it can be crashed in such a way without exceeding some set of cost which is not given here, but trying to understand that as I decrease the number of days, what is the overall effect on the job and the time duration. So, for my first highlighted activity is A. The time initially, if you remember, again with due permission and apologies to the students, I will go back to the last slide. So, here A, where I am hovering my pen, A is 9. So, 9 is now going to become 8. So, A becomes 8. The number of days technically was basically 22. So, critical path has decreased by 1, because still it is critical, this path which is A, D, G is still critical. Now, it is 8, it is not 9, 8 plus 8 is 16, 16 plus 5 is 21. So, if you see, the number of days is 21. Now, you will immediately ask what is the increase in the cost. So, now if you go to the cost structure of A, so again I will go back to the cost structure. So, if you see the first row, cost structure is given by the slope of 2, that means per 1 day decrease in activity duration for activity A, your total cost increases by 2 units. So, if it is 2 units, so let us go back, total cost was 55 as you see in this slide actually when there was no crashing. Now, obviously, it will increase from 57 to 55, I am sorry for that, it will increase from 55 to 57. So, as noted down here. So, if you consider 1 day reduction in A decreases the time duration from 22 to 21 and increases the cost from 55 to 57. So, now I will ask whether it is possible to reduce this further. So, let us go step by step. So, this is the situation of the network diagram. Here everything remains same, but only concentrate the highlighted red color which is A. A duration was 9, now it is 8. So, based on that I have drawn the next instance of the activity on arc diagram for this problem. Now, let us further reduce A. I am only considering A, it could have been done for the others, but let us go in one sequence of steps that I reduce A now reduces from 8 to 7. So, now the overall duration of the critical path which is ADG is basically 7 plus 8 is 15, 15 plus 5 is 20. So, as rightly pointed out, 21 decreases by 1 units to 20. Now, on the other end we will also see that what effects does it have on the cost. So, cost had increased from 55 plus 2, that makes is 57. Now, 57 will again increase by 2 units, because this is a linear cost marginal rates, if you remember I had mentioned that. So, now it will increase from 57 to 59 as pointed out in this table. So, in this slide, and then I will again draw the actual network diagram. So, here again the network diagram, everything remains the same, only A number of duration which was 8 earlier has now reduced to 7. So, now let us again pause and see, just this is a footnote which I want to add. Well, you may be thinking that this work is being going on where I am trying to reduce A by 1 units, that is fine, but does it bring any other activities into the critical path? Let us see, it was 21 as of now by reduction of the number of days of 1 unit in each step. So, if I want to find it out whether there is a reduction in any or change in the critical path to other set of activities, the answer is no. Why? So, if I basically consider the sequence of activities ACF, what is that? 7 plus 5 is 12, 12 plus 5 is 19. So, 19 is definitely less than 7 plus 8 plus 5. So, hence it is still not critical. Which is not critical? Let me repeat it. that set of activities A, C, F is not, still now it is not critical. Let us look at the other set of activities. 8 plus 5 is 7, 7 plus 5 is now equal to the same value as 7 plus 8 plus 5, which means now if you see, and as rightly pointed out in this diagram, there are two sets of critical paths and both have been marked as red color. So, the first set of critical path is 1 to 2 which is A, 2 to 5 which is D, and 5 to 6 which is G. So, the total sum is 7 plus 8 is 15, 15 plus 5 is 20. The other critical path is 1 to 3 which is B, 3 to 5 which is E, and 5 to 6 which is G. So, hence again add up 8 plus 7 is 15, 15 plus 5 is 20. So, that means now rather than having only one critical path, now you have two different critical paths. So, now let us pause here 1 minute. In case I will show that in detailed calculation later on, but let me explain. Now, if there are two critical paths, if you reduce G by 1 day, so it will basically affect both the critical paths at the same time. So, in that case, if I want to find out that 1 day reduction in the critical path which is actually happening from 20 to 19, what is the actual critical paths now? The one is A D G and B E G. Duration is 7 plus 8 plus 4, and here it is 8 plus 7 plus 4, which is in both these cases it is 8 plus 7 is 15, 15 plus 4 is 19. Now, you will ask the question that does any other path become critical now? So, let us answer this question, because there is only other set of activities path is 7 plus 5 is 12, 12 plus 5 is 19. So, till now what we have is that 8 plus 7 which was 15, 15 plus 4 is 19, which means that the moment we reduce from 20 to 19, the rest set of activities which was still not critical now becomes critical. That is point number 1. Point number 2 is that you will ask what is the actual cost increase. So, the cost increase has increased from 55 to 57, 57 to 59. But if I reduce the job G by 1 day, so I will basically go back to the sequence of the job reduction which is happening. What is the marginal rate? So, let me go back there. So, for G, the reduction 1 day reduction cost increased by 8. So, which mean that the total cost which is now the new one is 59 will now increase by 59 plus 8, which would basically become 67. So, this I just wanted to explain. So, let us proceed with the problem. So, now here that was one sequence. Now, let us see the other sequence. So, okay, let me before coming to this diagram later on, let me explain it with a different set of tables. So, there are different instances based on which you can reduce the overall critical path, the costs will increase, but you need to find out which is the minimum cost. So, you basically draw different sequences and take a decisions accordingly. So, now consider you are trying to reduce A and E at the same time. So, A basically now reduces in such a way that it becomes from 7 to 6, and E basically which was 7 now reduces 6. So, let us go back what was A and what was E earlier. So, A was 7 and E was 7. So, now A has reduced from 7 to 6, E has reduced from 7 to 6. Now, if it is reduced by 1 unit, so let us see what is happening. So, the total duration which is happening and the reduction of the number of days which is happening would now be, it was earlier 20, now it is basically reducing by 1 unit and becoming from 20 to 19. Point 1. Point number 2, the cost was 59 and that had an increase from 59. If we only consider the activity G, if you remember, that has increased from 59 plus 8 which was 67, but now we are taking a different approach. If cost is increasing on two fronts, one for A and one for E, we will try to answer that what is the marginal rate of the increase of the total cost both on account for A and E, all of them or both of them reducing by 1 days each. So, here the marginal rates for A, if you remember, was 2, marginal rate for E activity was 2. So, hence the cost increase would be 59 plus 2 which is 63. So, you will try to answer this question that trying to reduce the cost of A and E separately, will it be beneficial with respect to the concept trying to reduce the cost of G, which was for G you incurred an extra cost of 8 units per 1 day reduction, but here in trying to reduce A and E separately you incurred a total cost increase of 2 plus 2 which is 4 units, which means that it is much more viable, much more logical to increase the cost by only 4 units by concentrating on A and E separately rather than only concentrating on G, which would basically increase your total cost by 8 units. Here I give you the diagram. So, this is basically now A is reduced from 7 to 6, E is reduced from 7 to 6, B remains as 8, D remains as 8, G remains as 5, C and F remain at 5 and 5. So, this is the actual network diagram for the total reduced network depending on the 1 units of reduction of the total number of jobs which has happened at the last stage for A and E separately. Now, let us come to the increase in the cost and the reduction of the days if we consider only G. So, now A to F are not being affected, G which was initially 5 is being reduced from 5 to 4. So, the moment it is reduced from 5 to 4, the total number of days for that path. So, now that by the word that part I mean there are now 2 paths which are being affected by G. What are those? That is A D G and B E G. So, if you see the total reduction is happening from 19 to 18 by 1 day and the increase in the cost would now happen by 8 units. So, this I have just changed it here, this is 8 units as you can see in this slide. So, it has increased from 59 plus 2 which is 63, 63 would now increase by 63 plus 8 which would become basically 71. So, now with the reduction of the number of days on different accounts for different activities, the total cost as of now is 71. So, this is the diagram which you have. Here A, B, E, D, C, F are not being marked by red, only G is being marked by red because it showed that what is the overall reduction in the number of days happening from 5 to 4. So, now again I concentrated on G in the same line, G is decreased in the number of days from 4 to 3. Again the increase in the cost would be what? It was basically 71. So, 71 would now increase from 71 plus 8 to basically 79 and the number of days reduction was already 18, it is being reduced from 18 by 1 day and it has become 17. So, here is the set of jobs which you have. So, again the overall cost structure, overall network diagram is shown as given. Lastly, we reduce the number of days from G from 3 to 2, the cost increase which would be now here it will be 8. So, it was 71 plus 8 which was 79, 79 plus 8 which is 87. So, this value would become 87 which has increased from 55 and the reduction of the days would be given corresponding to the case where G is decreased by 1 day. So, now this is the total network and if you see now all of them have become critical because the number of days is, if you count out any of them, is 6 plus 5 11, 11 plus 5 is 16, 6 plus 8 is 14, 14, 15, 16 here also and if you see B, E and G is 8 plus 6 is 14, 14 plus 2 is 16. So, all of them have a duration which is 16. So, the total duration has been crashed from, as mentioned, from 22 to 16 with the increase in cost as mentioned here. So, with this I will close this lecture and continue in the 32nd about the concept of more crashing and JERT and QJERT concept. Thank you and have a nice day.